Hello everyone, welcome to our second part of our computer programming in Scala. In this part we look at control structures, and first of all we discuss conditional expression in control structures. And as usual, if you haven't subscribed to this channel, click on the subscribe button and the notification bell so that you'll be prompted or get notified when new videos is uploaded. Now today our main objective is to introduce you to control structures in Scala, explore different combinations and uses of Scala if expressions, understand code block in Scala, and be able to identify the pathways in a program. And finally, discuss scalar match expression as well. So, what is a control structure? Now, there are three commonly used structures in programs. The first one is called sequence. Now, sequence is a set of statements that follows one after the other, or that runs in a linear order. So when you start a program, you can say declare variable, you input, you print, you stop. It means it is in sequence only. We also have selection. Selection allows different pathway through a program. So when there's a selection, your program may branch based on a condition. So maybe you have two set of codes to write or to execute. The code or the program may execute code A or code B based on a condition. So it means when you are coming from the top, you reach a junction, you make a decision. Why select left or right based on a condition. And mostly we use if statement to depict selection statement. We are going to use examples to show you. Then we also have iteration. Iteration is when a code segment repeats itself until a condition is met. Now, so far, all the codes we have tried are only in sequence. So in this lecture, we are going to look at selection statement where we can use the if and the match statement to control the flow of statement. That's that in Scala, control can themselves also be used as an expression, which can also return a value. So in essence, we can say that control structures determines how program statement execute. So whether it's going to execute sequentially, or there's going to be a selection, or there's going to be iteration. So we are going to concentrate on selection. In this lecture, we have already seen sequence. All the codes we have written so far are in sequence only. So in this lecture, our concentration will be on selection. Now, when we are dealing with control structures, we are going to be talking about blocks. You already know what is a block of code. Applications use compound statements to group together a series of code statements, which is known as block. And we use these braces to delineate the block or to show where the block ends. And blocks are very common in control structures. Now we are saying that rather than having program execute the same line of code every time it runs, it is often necessary to have a program make decisions based on a condition. So for example, we have a block of code where we have this statement. This block of code will only be executed if the expression or the condition here is true. So this is just an algorithm or a pseudocode. Say that if the condition is true, execute this statement, else this statement will not be executed. And most often this condition here must be an expression that can be evaluated to true or false. So I can say that if your age is greater than 20, then execute here. So any age that is not greater than 20 will not execute this block of code. Now we can depict it in flowchart. So we have our start. We take the condition. If this below condition is true, we execute this code. If it is false, this code will not be executed. It will use this branch and come and end the program. So this is a simple if-then statement. So if condition is true, execute. If not, it ends. So the program doesn't care about the else part. Now, we can have the else clause also. Now, see that an if statement can optionally be extended to include an else clause. So here we have the condition. If the condition evaluates to true, we run this statement. If it evaluates to false, it means the else part. We run this statement. So assuming I can say that if the gender is male, run here. Else means the gender is not male, then we run here. So the code block is executed depending on whether the condition is true or false. When you look at the pseudocode or the flowchart, we start a Boolean condition. If true, we execute this code. If it is false, we execute the alternative conditional code. Then we end. So you have two sets of codes. Both code will not be executed at the same time. Either it executes this line or it executes this line. Then all joins together to end. Now see that what is a condition? A condition simply evaluates a Boolean type value that will return either true or false. So when you look at this expression, assuming we accept a student marks into a variable mark, then check, is the mark greater or equal to 40? This can be true or false. So when you're evaluating here, if the mark is greater or equal to 40, then it means we print on the screen pass. Else, it means it's not greater than 40, which means less than 40, below 40, then we print fail. Now see that the condition here must be a Boolean expression. So that every if statement has a condition. This is in fact a Boolean expression as a result of the condition that will always evaluate to true or false. That is the two possible values of a Boolean type. Now we can also say if true also or if false, but mostly we put an expression so that we can evaluate it to true or false. Now as I said, we have these relational operators: equal to, equality, not equal to, greater than or equal to, less than or equal to. So this operation can be used in this form in a conditional statement. So mark greater than or equal to 40, we run this block of code. If x is equal to y, we run this block of code. If z is not equal to 0, we run this set of code. Each of these expressions will evaluate to true. Okay, we can also use the three basic logical operators as part of the Boolean expression. So we have the AND, we have the OR, and we have the NOT. So for example, we can say if mark is greater than or equal to 40 and mark is less or equal to 100. So it means both conditions must be true to execute this. We can also say if x is equal to y or x is equal to z. This is the OR operator. Execute this. So it means at least one of the conditions must be true. Then we can also use the negate, the NOT, to negate this expression. Now so let's look at different uses of if statements. So we have the if condition statement and the else if statement. So you see that a single if statement with no else clause, it means it executes only one statement. We can add the else clause to have two branches. We can also have multiple if statement using what we call the if-else statement. So you can say if condition is true, run this. Else if this condition, run this. So you can have multiple conditions. Okay, so I can say if your mark is greater than 70, run this. If it's greater than 60, run this. If it's greater than 40, run this. Else, fail. So this is how we represent it in flowchart. So this is the first condition. We run this block. If this is not true, is false, we come and test this second one. If it's true, we run this. Else, we go and test this one, we run this. Then we run the fourth one. So that's how it works. Now we are saying that when you have multiple branches, only one branch will execute. It will effectively drop to the end of the completion of the branch. So when you have multiple conditions, only one branch execute at a time. So we say that you should put more general condition after a more specific condition. If not, you're going to have a logical error. So for example, we have this. The order of the condition is very important. Assuming we bring if mark is greater than 40 at the beginning, that means every mark, whether 70 or 60, will print third. So we need to arrange the marks in that order. The highest first, so that if it is not 70, it prints this. Then it tests for the lower one, 60, 50, 40 in that condition. You bring 40 first, all your marks above 40 will print third. So we want you to understand that the order of the arrangement when you are using multiple if statement is important. Okay. Now, if also you want to test different conditions and want them to execute, then you need to separate the if statement. So here you are saying if mark is greater than or equal to 70, print this, which means it will come and check this one also. Even after printing 70 first, it will come and check this one. But in this instance, this code is redundant. Assuming it is 70, you print first, it will jump to here and check again, and it will print 2.1 again. But there are instances where you want to test multiple conditions, you want to execute both, then that one, you can do that. For example, we want to check if the first name is empty, then we print this. Now the fact that the first name is empty or it's not empty does not mean that the surname will not be empty. So in this instance, we can have independent if statement. We are okay. If you are going to, or if you spread this in an if else, it will just execute the first one and skip the other ones. So we can have different or separate if statement. So test for first name, another block of if statement to check for surname, to check for surname, another one to check for address. So in this instance, this type of coding is acceptable. We can also have nested if conditions if you want. So if this condition is true, we check an inner condition. So we can have this. If A is greater than B, then we check. If B is greater than C, then we print. So we have nested if statement. So the pseudocode will be as this. If the condition is true, we run this. We check for the next condition. We run that in this example. We can also have these combinations of if statements. So if the condition is true, we run this code. Else, if this condition is true, we run this. So these are some of the examples that we can combine our if statements. So let's pause this video. And when we come back, we look at using the block to brace or to express the block of statement that we are going to run. See you in the next video.